Alright, time for another draftphysics.com, debatephysics.com also, but the debate kind of sucks. Can't get anybody to engage in the debate, in any kind of coherent way, where one person presents an argument and another person presents the counter argument and explains. So it's all very one-sided. Me doing the truth and they just do crap. So it all started years ago. And the continuation was basically when Steve Mould, who gets 1 million views per video, basically said there's no law of conservation of momentum, and the law of the lever, and Archimedes, idiot, wrong, got it all wrong. That the real physics is kinetic energy is conserved, and momentum can be sacrificed at your whim. And I'm the only person who showed up to say, no, that can't be true. Your own physics says otherwise, and it says otherwise for ever, almost. I mean, we're going back 2,000 years. 2,000 years ago, Archimedes basically made this rule, okay, that, the farther you put something out on a limb, the radius will proportionally increase the amount of momentum the object will have. So twice the distance, twice the weight, 3 times the distance, 3 times the weight. Very proportional, very reasonable. And the weight just has to do with how much work you have to do to move it. And something twice as heavy requires twice the energy. And it's all neat and tidy. And it's not broken physics in any way. And now they're breaking it for no good reason. So, the Dispar Lab guy just keeps doing these experiments, so I will illustrate the silly experiment and explain, all the ways he could be doing it, and also that what he's trying to prove is flat Earth stupid. You're just not going to debunk or undo all of the already done kind of experiments. Now the real truth is they don't do any of these basic physics experiments. They just tell us something and we're supposed to believe it. And they've never really analyzed anything as simple as dropping 4 pounds 1 foot and dropping 1 pound 4 feet. They just tell us what the answer is. They don't show us any of the answers. So I'd like to just link to a video that makes it really clear. I mean, lots of them do a bit of it. They talk about ice skaters putting their mass in. Okay, so the mass has very little momentum, and then putting the mass out, it has a lot of momentum, and therefore they slow down. Okay, that's the velocity part. So you increase the R, and you have to, decrease the velocity to maintain the same momentum, because you're not putting any new energy into a system. And so obviously their law is, so the L is angular momentum. It just means momentum. So it's mv equals rmv. So you're just saying the further away you put a weight and cause it to move, it's twice the velocity at twice the distance. So the distance is completely proportional to the velocity, and so therefore the r and the v are interchangeable. And obviously if you double anything in that equation, you have to have something else. So if you double the radius, you have to half the mass or half the velocity. You have to half something. All right, and so it's that simple. So anyway, so leave us get to the arguments that have been made that have been ignored. So it starts with Steve Mould saying that levers, the simplest machine. And I could go one step simpler, in the sense that I could just use the gravity balance, okay, something suspended from above the lever, and that means that it will restore itself. It will attempt to fix its imbalance, and it will oscillate in the presence of energy, because what basically it's doing is every time one side swings in the upward direction, it collects, the lever itself swings a little, and there's more mass on that side. So the mass increases, okay, as the lever moves up on the side that's moving up. And vice versa, it decreases on the side going down, which makes it more buoyant, so to speak. So you're just basically switching the mass from one side to the other as it oscillates. And the fact is that we'll oscillate perfectly, okay, obeying the law of the lever, obeying the conservation of angular momentum in the sense that a half mass going twice the velocity will equal a full mass going just the one velocity. And that all works perfectly. All right, so their argument is this lever, you could take it a step different, okay, put a fulcrum in a different place, and then you could put masses on it. And the argument, the simple argument is if you couldn't see what's on this other side, there was a barrier, that theoretically, okay, putting a force in this side, you can't really tell the difference between this and this, because the momentum of those two objects will be the same. The energy you have to put in to create their motion and their eventual MV will be exactly the same. All right, because of this fact that it's tied to this mechanism that forces it to be twice the velocity here. Okay, for every motion here, it's going to be twice the motion there. Now, I did this balance with a 4-to-1 ratio, and it worked perfectly. So yeah, you can extend that logic. So Steve Mould says no, you won't be, first you will be able to tell the difference, and second, this object can only go 1.4. So if I was to put a force in, like just dropping this weight at one location, the expectation is certainly that this object will leave with almost the same momentum I put this one in. I lose a little bit because the lever has to move. So I have to put energy into the lever, so that energy I'm not going to get back. And the simple truth is that I'll get 90% or 99% or some high percentage, depending on how well I've designed the experiment. And the expectation is that obviously, if I'm going to get the momentum here, I have to get the momentum here. That's the law of conservation of momentum. It can't leave with 1.4. Okay, it has to leave with 2.0. So if it doesn't, I would argue it's because you didn't do the experiment right? There's got to be a problem somewhere. And so that's what this whole argument is about. And the fact is now I'm in the position of defending conventional physics and, conventional theory. And, in all these other cases, I'm the one opposing conventional physics. So to fight me, now obviously Steve Mould doesn't know who I am and doesn't give a damn and all that kind of crap. And so for no good reason, he decided to do a video where he starts defending kinetic energy theory and destroying momentum. So basically his argument is that something as simple as a lever destroys conservation of momentum. So I put a force in here, a certain MV, and I don't get the same MV out here. All right, I get 30% less. Okay, and if I do it with a 4-to-1 relationship, then it will be exactly half. I'll lose 1/2 of the momentum. So 1/2 of the MV will be destroyed in some magical way that I can't diagram, and they won't diagram it. They won't explain where it is. Where is the 50% of the momentum? I put 50% in here. I put 100% in here, and I get 50% out on the other side. Where's the rest of it? What happened to it? No, I'm saying obviously none of that crap happens. All right, so the disk bar is doing these, I would just argue, silly experiments. I'm not going to bother showing them because they're just silly. And so what he's doing is comparing the rotation speed of when he puts light masses, presumably, half masses, and full masses inside. Okay, so he's saying that he's proving that the law of conservation of angular momentum is not true, because it's his assertion that this moves easy. Okay, this will spin like twice the rotational speed for the same energy. So I put the same energy in, and this will rotate. Well, let's just do it with arrows. Okay, that this will rotate this far. All right, and by their theory, of course, this one would only go 1.4, I guess, but it'll go substantially less. Okay, so this goes to the full 90 degrees, and this stuff on the outside barely does that, half of it or so. So it's terribly much more difficult to create this same momentum here as you have here. Now, I could argue about wheel balancing and lots of gears and all kinds of different ways and different experiments that demonstrate that this doesn't happen, that it isn't harder to move the light masses on the outside than it is to move the heavy masses on the inside. But he's experimentally proving it, okay? So his mechanism is kind of silly. He's got a drill, a Dremel, I think, and he's just going to rotate 2 sticks, okay, wooden dowels, by the way. And he's got rather substantial weights on them, so who knows how much flex is in them. And that's how he's doing the experiment. He gives them a jolt and accelerates them, and he finds that jolting them, the one with the mass on the inside spins faster. So now I would have argued that there is a difference between the 2 experiments. So if you isolate the 2 experiments, there is a difference. This one obviously weighs more than this one. And then you have the one intermediate, the one that he doesn't do, which would be interesting also, is the 3rd experiment is to have the light mass on one side and the heavy mass on the other side. Okay, then you have 3 versions, and you can see if that one is right in between the other 2 in terms of its difficulty to move. It's a difficulty to absorb momentum, and that it doesn't take the same. It takes more energy to move the half mass twice the speed than it takes to move the full mass 1 unit of speed. And that's what all this argument comes down to. Is momentum conserved or is kinetic energy conserved? And again, the conventional theory forever is, okay, that momentum is conserved. Hey, rum. I didn't realize it. Rum. Yeah, well, it's a V, but whatever. I probably could spell something with the... See, it doesn't matter how you arrange these letters. You could have an R first or a V first or an M first because they're all interchangeable and inversely tied to each other. All right, so let's argue the better way to do the experiment, I suppose. I could argue, but the thing you're really trying to do is find out why is he getting his results. Now, the obvious thing to do, I would have done this experiment when I had a very perfect thin little steel bar, and I hung magnets off of it and used it to create an oscillator. So it oscillated this way. Now, I could have spun it, could have given it energy and spun it and said, well, how much energy does it take to spin? And is there a different amount of energy to require for it to spin? And the obvious thing I would do is if they started spinning differently, well, I might figure out that maybe this is a little bit off. Maybe I don't have my distances quite right. And so I'll just move the mass in a little bit. Or if this one's moving too fast, then I move it out a little bit. So that's his argument. This one's moving way slower. So just move it in a little bit, and then it should move faster and faster, and see how far you have to move it in before it's rotating at the same speed as the heavy mass. That would be a simple test to do. The other thing you can also do is before you even start, you got to figure out whether you have your distances right. So you take one of your sticks and put your one mass on one side and balance it and make sure that you've figured out these locations correctly, that where you have the 2 mass and where you have the 1 mass is proportional to the 2R, okay, you're supposed to have here, and the 1R you're supposed to have here. But he didn't do that. And again, just do this experiment with that actual arrangement and see what results you get. So again, he's saying he's proving it. Okay, he's got a picture of this thing happening. Now, there's no evidence the drill puts the same energy in. He doesn't do it exactly 100 times or anything, so we don't know how many versions of the experiment he superimposed on each other. We don't know whether he took the third trial and put it on top of the second trial, or the first trial with the outside versus the inside. So we don't know how much shenanigans is involved and even how he's compiling the data. We know that Eddington, doing the famous Eddington experiment in 1919 regarding the eclipses and proving that light is twice as bent by gravity, we know that they decided, this slide fucks our results, so let's just slide that one off the table and have it crash on the floor, because that one's not too good. And so there's a lot of that in this, I'm sure. That there's a lot of selective confirmation bias in terms of creating a result to present. All right. So again, the argument is if you're going to tell me it takes more energy, and then you have to show me that it makes more energy, that somehow when the lighter things are on the outside, that somehow they can whack things harder. If it takes more energy to move them, then their movement must also contain more energy. And again, it just doesn't work, because we already know that gears work. We know that we can balance tires. We know we can do lots of things, and the simple principle is, again, RMV. That's angular momentum. That there isn't any trick to it. It's really, really simple. And again, it's 2,000-year-old theory that they're knocking down. So they're saying for 2,000 years, for the last 300 years since Newton, we haven't been able to figure out that there's no such thing as any kind of proportionality to angular momentum. That lighter things are harder to push than heavy things. I mean, that's their argument by some magical theory that I can't understand. Now, obviously, this does create a paradox. I mean, that's just a simple fact, is this experiment shows you that you really do have to choose the idea of kinetic energy or the idea of momentum as being meaningful as a description of energy, because they both can't be true. Because the simple truth is with the lever, it creates this huge paradox that if this leaves, the lighter thing leaves with twice the velocity. Okay, I put the heavy thing in. I now have the half mass, 2 units of distance, and I actually get my twice the velocity. What does that mean? Well, it means that this energy coming out is, 33% is it more kinetic energy, right? Twice the kinetic energy. It's twice the kinetic energy. So I've doubled the kinetic energy merely by converting from a big heavy thing to a light thing. I now have created free kinetic energy. I had a certain kinetic energy going in. So it's just like the car thing. You have the 5 mass and you add 5 mass in a graceful connection, and you end up with a 10 mass with 1/2 the velocity. And you've lost half. 1/2 of the kinetic energy is gone. Okay, you lost it. It's as simple as that experiment, and there's no explanation. I mean, they say, when the two things combined, it was a terrible crash, and lots of sparks flew off, and pieces flew off, and many were killed. And none of that happens. You can so gracefully combine the two objects that there's no catastrophic loss of any kind of energy, especially when you drop them. So I mean, just for the sake of making an argument, you can just drop them on 1 millimeter. You drop this object on top of that object, and the fact is you've added energy. You haven't subtracted any. You added it. You put more stuff going in this way. Okay, now this way is useless to its motion this way, but it's clear that you combined them using gravity. You haven't combined them taking away from their velocity in any way. You haven't changed this velocity by introducing one this way. Then that's a simple principle that right in the core of physics also. All right, so the simple truth is it is a paradox to believe in both. The lever is basically telling you have to choose one. Either it leaves with 2 velocity and there is no kinetic energy because I can't make free kinetic energy, so kinetic energy is rubbish. Or it does leave with 1.4 and somehow I destroy 1/3 of the momentum, so momentum is garbage and doesn't mean anything. But you can't have it both ways, and the fact that nobody will concede you can't have it both ways, that they really think there's some possibility that both these theories can explain this simple lever, both theories can't explain what it does. You have to choose one, and once you've made that choice, you're stuck. You can't decide, well, I'll just wait for a different experiment to show up and I'll use kinetic energy for this one and I'll use momentum for that one. I mean, that's not science. That's rubbish. That's nonsense. Saying a duality is acceptable and I will at my own discretion, decide when I'll use kinetic energy and when I will use momentum is nonsense. The simple truth is all the experiments point to the simple truth that momentum is the only real thing. And again, I will use the ballistic pendulum or the spaceship example where you're just saying, here's a thing. Let it collect energy. Okay, something hits it and sticks. What's going to happen? Is the KE of this object going to get into this object? No. The only thing this object can do is take its MV and combine it with this one's M and create a new MV out. And that's all that's going to happen. And you have to conserve the amount here with the amount here. So as the mass goes up, the little velocity has to go down proportionally, and you end up with the same momentum the object had. That's the momentum of the entire object. I mean, it's a decisive proof, and it happens every single case with a ballistic pendulum. Every time you try to capture kinetic energy, all you capture is the momentum. That's all. You never get any of the kinetic energy, in the sense that your number is always something less than the momentum and nowhere near any reasonable proportion of the kinetic energy. You're losing half or more. Okay, and a lot more in the case of a bullet. It's 99.94% of the kinetic energy is gone. I mean, I really shouldn't have to do this for years. Where's the counter explanation? Where's somebody who's just going to take what I just did in this last 20 minutes and explain how I said something incorrect and I made a huge, gigantic thought mistake. I reasoned poorly. I applied wrong logic. Where is that explanation? I mean, all these people pretend to care about the truth and science, and they just let this pile of nonsense, this stupid argument that shouldn't even be an argument, exist. And that's just, it's a terrible commentary on you, the audience. That's all I'll say, okay? I'm doing my job. I'm being a functional brain, doing logic and reasoning, recognizing a paradox when it exists and saying, let's fix the paradox. And the only way to fix it is to realize one of these ideas is a good one, momentum, and one of them is just a silly fable accepted 300 years ago for no good reason. And that's the absolute truth. It was accepted for no good reason. Nobody did the show me thing. They didn't prove it. They didn't demonstrate it with experiment. They contrived silly stuff. Again, I mean, you know, just for the historical record, okay? Just understand, this is the kind of crap they used to make their argument. They took a pile of sand, okay? And then they hit it with big slow thing and fast little thing, okay? So a big M and a small v and a big V and a small m. And then instead of calculating how much sand was displaced, that is how much sand ended up moving some amount of distance, they just said, which one sent sand the furthest? Yeah, and that's what they said. So obviously the thing with the high velocity sent sand further because it can give it high velocity. A slow thing can't make things go fast. A fast thing can make things go fast. So yes, some of the sand went very far when the light thing hit. And none of the sand went very far when the heavy thing hit. But the heavy thing moved just as much sand. They both had the same MV, by the way. Same MV. Just in different arrangements. Now, do you think that's a rational experiment? I mean, as an honest opinion, can you just tell me your honest opinion? You think that's going to tell you which object has more energy? Is just by this bias of course, the fast thing can make things go fast and the slow thing can't. So that means it has more energy. I mean, that's just so bad as a proof. And you can't see through that? I mean, I'm not expecting you to understand the, pointy arrow versus really, this kind of stuff fools you. If I put a point on a stick and then I have a stick with no point, and then I launch them into something and the pointy one goes in deeper, it means the pointy one has more energy? You'd fall for that? What's your answer? Yes, you would. Oh, okay. So that's how bad it is. All right. So I think that's enough of a video. So till the next time and such and so forth and whatnot. It's just really sad and pathetic and awful that no one will engage in the conversation to defend anything. Any kind of, let's be reasonable. Okay, yeah, let's be reasonable and fix the paradox. No, they'll just sit there and say, no, it's okay. Steve can believe in momentum one day, and then tomorrow he can believe in kinetic energy, and then the next day he can believe in KW. He will just keep changing the letters and keep changing the thing we believe in. Today the Holy Ghost is running the world. Tomorrow it'll be Jeebus, and then the next day God gets to do it. Yeah, they're sharing the job. Ugh, shit. Actually, when I was looking at videos to try to find a reference, there was some guy in the space station, right? So one of the astronaut kind of videos, and spinning a thing and talking about angular momentum. He had a silly little cross around his neck, and it was floating around. It just was like, oh, come on. Oh, you have to be really smart to be an astronaut. And it's just like, how could somebody be really smart and believe this bullshit? I mean, how could that be possible? It just doesn't make any sense. How? How is that possible? It's just beyond, it's beyond that's another paradox, and this paradox doesn't have some simple answer, except he's fucking crazy. Because what else could it be? I mean, you just can't figure, I mean, how could he fall for a silly Santa? It's like having a Santa Claus sticker on his shirt. I mean, it's ridiculous. All right, anyway, just amazing. The world is so fucked. By all you dumbasses who just keep putting your big fucking sponge finger on and going, yeah, we're number one. We got the number one science and everything. We're number one. Yeah, no, you're not. You're just insulting neurons. I mean, all of this evolution to gain this capacity to do reasoning, and you refuse to do it. Ugh, it's just so pathetic.